This is an early test of a homemade hydrogen generator, a device capable of producing a mixture of hydrogen and oxygen gas from water using a process called electrolysis. An electric current passes between electrodes placed in the water, breaking the molecules into these two gases. The generator uses a wet cell design, which means the electrodes are submerged in water. Although this design is simpler and easier to build than the dry type, it is less efficient. The current can bypass some electrodes through the surrounding water, reducing overall efficiency. To counter this, the generator uses only two large electrodes, made from 20 mesh metal netting, each rolled into a cylindrical shape, one nested inside the other. Between the electrodes are 3D printed spacer rings that maintain a consistent gap of about 8 millimeters. This is important because the generator has only two electrodes, making it essential to maximize their surface area and minimize the distance between them. Additionally, water conductivity is improved with sodium hydroxide, which acts as an electrolyte. In the lid of the container, 3 holes are drilled, 2 smaller ones for the electrical connections and 1 larger opening for the gas outlet tube, which has inner diameter of 8 millimeters. During operation, the lid had to be sealed with hot glue because it was leaking too much gas. How to operate the generator? First, fill the container with water and a small amount of sodium hydroxide. After everything has dissolved, place the lid on the container with the electrodes submerged in the water. Then fix the gas outlet tube into the lid, and once everything is sealed with hot glue, the generator can be connected to the power source, in this case, a power supply. During testing, the power supply was set to output 5 volts and 7.5 amps of current. As soon as the power source is connected to the electrodes, the generator starts producing hydrogen and oxygen gas. For the future, some modifications should be made. Currently, the container is made of glass, which could shatter in the event of an explosion of the gas mixture inside. The second issue is that the lid is made of wood, which can rot and deteriorate over time. A new plastic lid will be made to solve these problems. The results confirm that the design is functional and effective, meeting the goals of hydrogen and oxygen generation through electrolysis.